Okay, so this is page 6 of the polynomial models book work. Let's go to this problem. On the same graph, sketch the curves y equals x squared and y equals 4 minus 1 over x for the values of x from -8 to 8 and from values of y -2 to 8. I gave you just enough room here to draw that. If you put the axes, you see that this is 10 up and down and it's 20 across. So if you put the axes here, it just fits. Okay, so this would be -2, this would be +8, and this would be like +8 would be here, -8 would be here. Okay. Alright, so let's draw the parabola first. So they say graph y equals x squared. If you want to, you could put that in your calculator. You remember the y equals x squared, that is a parabola, and it's the most basic parabola. Okay, it looks like that. What are the points? Second table. Okay, the points are 0, 0, so that's a point. 1, 1, that's a point. 2, 4, that's a point. 3, 9, that's off the screen. Let's go up a little bit and get the negative points. Hey, what do you know? It's a parabola, so symmetrical. We don't even need to really look at that. And then we join the points in a smooth curve. Okay, so that is y equals x squared. Now let's graph 4 minus 1 divided by x. We'll definitely want to put that in the calculator. 4 minus, and always put parentheses around a fraction. And if you really want to be safe, you could put parentheses around the numerator and denominator too. If you're not sure of what you're doing, doesn't hurt. Okay? Now let's see what the points are. Okay, we'll just graph it to see what we make sure. Yeah, we should get a hyperbola because there's a 1 over x in there. But to see the points, we're going to have to do this. Okay. So you can see that for x equals 0, there is an asymptote for the parabola. The x equals 1 point is 1, 3. Maybe I use a darker green. Okay, 1, 3, and the 2 point is 2, 3.5. 2, 3.5. And let's see, 3, 3.667. Let's see when they get to 4. Well, they don't really. Could 4 be an asymptote? It might be. Okay, and then there's an asymptote at x equals 0, so we know that it goes down like that, right? And then if we go to the negative values of x, we should see something that's like a reflection of that. So -1, 5, -1, 5, that's 4, -1, 5, and negative, looks like there's an asymptote at 4, doesn't it? Oops, that's terrible. Okay, that's fine. Okay, and if we look at it, you can see there's a 4 there, so actually there is an asymptote at y equals 4. Okay. So find the coordinates of the points of intersection of these two curves. Okay, then you definitely want the calculator. Remember that the points of intersection are here and here and here. There's 3. So we're going to use the graph on the calculator, and we're going to find that intersection point, and that intersection point. If you want to, you can zoom in a little bit more. Let's see if we're on Zoom Standard. Okay, and then we're going to now we're gonna use second calc and intersect, and first curve, yes. Second curve, yes. 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 Okay. And sometimes if you have a curve with an asymptote right at x equals 0, even if you press yes, it doesn't, you need to like move left or right to get off of that point. Okay, that's why it wasn't working right now. And then your guess is, and I want to move close to the point that I want, so let's do this point first. I almost put it right on top. So the answer for this point would be negative 2.11, comma 4.47. Now let's find the other point, second calc. And then we go to intersect. Go 5. It's faster. And then we use, oh, first curve, yes. Second curve, yes. Where's your guess? Well, we're going to move over. And you can see we're going the wrong way, but oh, all of a sudden it comes out the bottom. Okay, enter. So the other point is 0.254. And remember, always put 3 significant figures unless they say otherwise in IB. 646, and that's a good rule of thumb for life too. Okay, and then second calc, and then we're going to do the last one. We just, oh yeah, first curve, yes. Second curve, yes. And then guess, we want to move close to this third point right there, right? And our third point is 1.86, comma 3.46. Okay? So those are the 3 points of intersection.